Now we will see how to derive equations of motion, useful for 11th standard students. First equation, we know that V is equal to U plus AT. And the next one is S is equal to UT plus half AT square. And the next one is V square minus U square 2AS. So these are the main equations of motion. In this V, final velocity. Final velocity means what? At the end of t seconds, whatever is the velocity, that is V. When t is 0, what is the velocity? That is initial velocity. A is acceleration. You should understand one thing. All equations of motion are applicable only for a body which is undergoing uniform acceleration. For uniform velocity also you can apply. In that case, acceleration is 0 uniformly. So you can apply the equations of motion for a body undergoing uniform acceleration. That acceleration can also be 0, which means uniform velocity, moving with uniform velocity. First of its kind, first equation generally we study in the class is V is equal to U plus AT. Very simple. You should know that it is applicable for a body undergoing uniform acceleration. Many of you will forget it when you do it in problems, when you use it in problems. So V is equal to U plus AT. How to derive it? Definition of acceleration says rate of change of velocity. Final velocity minus initial velocity, change of velocity. By time taken for the change of velocity, rate of change of velocity. When you divide it by time, it becomes rate of change of velocity. So rearrange it. AT is equal to V minus U, which gives you V is equal to U plus AT. Hence the derivation. This is algebraic method. You can even derive using graph or using integration, but this is purely using that algebraic method. V is equal to U plus AT. Straight it follows from the definition of acceleration. Then next one, S is equal to UT plus half AT square. S is equal to UT plus half AT square. What is S? Displacement. What is U? Initial velocity. What is A? Uniform acceleration. So here what you should do, this displacement is average velocity into time. Please note that you can even include the vector concept into this. So see, for previous equation you could have written it as V is equal to U plus A into T. We'll have to apply vector addition there. So but my main aim is just to derive in a simple way the equations of motion quickly. So this and all we will give comments later on, or we will take it up later on. But for the time being, we just do it in a very normal way. Assuming there is no change in the direction, it is moving in a straight line. The body is moving in a straight line. Okay. So S is equal to U plus V by 2 into T. What is this? Average velocity. What is this? Time duration. Why do you take average velocity U plus V by 2? Please note very important point, average velocity by definition is net displacement by corresponding time taken, or even you can say total displacement by total time taken. That is the definition of average velocity. We can consider it to be U plus V by 2, it will become equal to U plus V by 2 for a body undergoing uniform acceleration. Proceed. U as it is, for V U plus AT by 2 here, this T you write here. So because I have used V is equal to U plus AT, which we derived in the previous case. So U and U add 2U plus AT by 2 into T. When you separate them and simplify, 2U by 2 into T, that is UT. 2U by 2 into T. Then AT by 2 into T, half AT square. So S is equal to UT plus half AT square. Okay. You can even derive it by other methods, but this is algebraic method. Third equation, V square minus U square is 2AS. And we know already v plus u by 2 average velocity into time is distance. We derived it already. Also, v minus u by t is acceleration by definition. Multiply these two equations, v plus u by 2 into t into v minus u by t, multiplying the left hand sides. Multiply the right hand sides, you get as. T and t cancels. V plus u into v minus u, which is v square minus u square. There is 2 here, take it to the right side, 2as. Hence the derivation, v square minus u square is equal to 2as. Understood it? Thank you.